All right, today we're just gonna work on the first page of these notes. The remaining we are going to do next time. The objective or the goal today is we are going to be using the technology. That means the Desmos calculator in order to write quadratic function that provide a reasonable fit to data to estimate solution and make prediction. So I have to make prediction or estimate solution, and I have problems over here. And in order to make the prediction, I will definitely be using the Desmos calculator. Now, number one thing, make sure that you pay attention to your questions and you read them carefully. Because if you're reading the questions wrong and you're typing the equation wrong, you're not going to see the correct answers. So first thing we do is, okay, hold on, let me see. We have been dealing with quadratic functions written in standard form. This is standard form. You can go back and check in your reference chart and you actually will see. So this is standard form. Let me see if I can write. Here, standard form. This is standard form. Which is y equals ax squared plus bx plus c. This is extremely different from y equal mx plus b, which is a linear function, and y equals ab to the power of x, which is exponential function. So you have to pay attention which equation you are using. This is practically quadratic. You have ax squared, x squared over here. In order to use the technology, first thing you do is I have some data that I'm going to use in my, use as table in my calculator. Look over here, it's x1 and y1. Always pay attention what do you have over there. And type in the values. I'm going to type in the x values first. So first question, actually, 0, x value, day after breaks. Let me read the question. After a break, 2 students came to school with the flu. Ouch, that's bad. The table shows the total number of students infected with flu X days after the break. So X represents days after the break. The data can model by a quadratic function. So that's what my clue is, quadratic function. Let me see if I have a highlighter here. Yes. So quadratic function, that's my clue word. It's a quadratic function. So pay attention on your things. This is my data. Days after, you have 0, 7, 14, 21. I'm going to use these values as X. And then students with the flu is the Y values, 2, 3, 5, 8, and these numbers. So I'm going to type those. And then I'm going to write the equation. And then I'm going to make some prediction. So let's fill in my table in the Desmos calculators. X values are 0, 7, 14, 21, 28, 35, 42, 49. That's table of 7. And Y values are 2, 3, 5, 8, 18, 30, 42, 55. So I got the graph, which, look at that. It's kind of, I can see 1/2 side. It should not have the other side because number one, you do not have negative days, and then you do not have negative number of people with the flu. People do not exist as negative, they're a real thing, and also days do not exist as negative because those are real. Next part, I'm going to type my equation. So if I'm typing y1 curly mx1 plus b, first of all, this is incorrect because my equation should be quadratic and this is linear. You can see this is wrong. This is not overlapping or tracing my point. So this is totally wrong. I am doing a mistake over here. It's wrong. Let's try another one. Y equal curly ab to the power of x1. This is exponential, which looks like it's tracing it, but it's actually not. It's not perfectly overlapping. This is not exponential growth or decay. you had a keyword called quadratic function, so I have to use that equation. So you have three different type of equation. That's what I'm trying to say. Your equation is y1. Well, actual equation is y equals ax squared plus bx plus c. But since the calculator is not smart enough, so I have to fix it. Number one, this should be called y1 because your table is y1. So there you go, y1 equal, no, it needs to be a curly sign. And then every x should be called x1. So this should be x1 and x1 over here. So there you go. I have the values. I have A, I have B, I have C. I have all these values with me, and you are going to see the curve. Ignore this part because that's not possible. We just gonna look over here. This is what I have. This is overlapping, kind of correct. Okay. So write the function. I'm gonna write the equation over here. It's y equals A is 0.0253887, so I'm just going to call it 0.025 x squared plus B is actually minus, so no plus, it's a minus 0.136, so I'm going to write it 14, I'm rounding it off. Bx plus C is 1.958, so I'm going to call it 1.96. I'm just writing it off. This is my equation. In just to help you, what I did was y equals ax squared plus bx plus c. I simply replace the values of a, b, and c. That's what exactly I did. All right, I have my equation. Now I have to do prediction, which is predict how many students will be infected after 60 days. So for prediction, there are two ways I can practically plug in 60 days is 60x. So I need to figure out how much over here for the 60. I do not know. That's what I need. It's a question mark here. Well, I can't put a question mark, so it would be an error. So what I'm going to do is 60 days is x. It's over here. Just keep going up, and you can see at 60. I had it almost 60 is 85, and days can't be decimal, so it has to be, I'm going to round it off to 85. So 85 people will be infected after 60 days. So after 60 days, 85, or roughly, my symbol should be there. Oh, I can't make the curly sign. I was trying to put the curly sign here. 85 people would be infected. This is a prediction. I'm not sure, so I'm going to use the word would be. So this is done. You have example number 2 that you have to do same way. Go ahead, do that, and we're gonna stop here. Next part, keep your notes in your save in your binder. We are going to work on those next time.